virtual reality for physiotherapy, functional reach training for automating walking patterns. In the project Virtual Reality for Rehabilitation, we focus on the questions how new technologies can facilitate natural interaction in a virtual environment and support, optimize, and even replace existing rehabilitation therapy. For this, we are developing a system that supports both patient and therapists. Our system consists of an application aimed at functional reach exercises in 2 virtual reality environments. We use an Oculus Quest to detect real-life hand movement and translate this into movements in the virtual reality environment. Within the first VR environment, the patient can see how far they can reach. We call this environment the Willow Game. It starts with a baseline measurement of the patient's arm length and reach capabilities. The arm length is measured by placing arms inside a green box. Once the arms are inside the green box, willow branches will spawn. A patient must then sweep away these willow branches. The amount of branches swept away and the distance of these branches determines the reach capabilities of the patient and uses this as a baseline for the following environments. In a second VR environment, the patient is in a virtual supermarket where they will have to collect groceries from a shopping list. The items on the list are determined based on the patient's baseline, which allows them to practice within their limit and in an interactive way. The supermarket is playable in multiple ways, either walking around with or without a bodyweight support, standing still or sitting down. The standing and sitting version of the game make it possible to practice at home in the future. After gathering the groceries, the patient can continue to check out their groceries at the cash register. In the walking version of the game, the patient will place their groceries onto the checkout conveyor belt. The products will then automatically move across the belt and the patient can pick them up at the end. Mostly turning and twisting is practiced in this way. After checking out the groceries, the patient will take a turn and will walk past a packing table, a cart mill, and a flower rack with bouquets. With the spare change, a patient can purchase a bouquet for a certain price. The game is still focused on balance therapy, but these kind of cognitive tasks make it also possible to challenge a patient in other ways. In the standing and sitting version of this exercise, the patient checks out their groceries at a self-scan. Future work includes other environments where patients will bring back their groceries to their car. This level will feature double tasks such as crossing the road with traffic lights with their shopping cart, which differs it from other levels. While a patient is playing a game, additional data is collected and sent back to the back-end application. This application analyzes the data, translates it into a patient progress overview, and makes it available for therapists to gain insights into the status of the therapy. During appointments, these insights could help the therapist to adjust the theory and set new goals for the patient. Future work also includes adding additional sensors to the system to quantify balance and gait, and having a system analyze patients' progress to come up with suggestions for new goals or moving into the next stages. In short, with this system, everyday situations are practiced in a fun and exciting way in virtual reality, which could make the transition to everyday life of a patient easier.